We've understood how to find process data in the IO-Link master. We've understood how to get that IO-Link master connected to our RSLogix software, and we've understood how to access sensor data through the integrated web browser that our IO-Link master can offer. But how do I get this information into a really usable form like I would see in RSLogix software? That's what I'll go over in this video. We'll start by doing it with the KTS. Depending on the time, we might do a couple more sensors. But the first thing we need to do is import our add-on instructions. So add-on instructions are found on the website. You enter in the 7-digit part number for the sensor. It'll pull up this page. You go to Downloads, then under Software, you can choose the function block for the software package you need. What I'm using is RSLogix 5000, so I download that one. That's going to look like, it'll look like this folder right here. You'll have documentation. You can go ahead and open up the documentation. I do have it open already. And then you'll have the library, which is the actual add-on instructions. So from there, you'll go back to your Logix software, and you'll import an add-on instruction. Import add-on instruction. The only one that I haven't done yet is for the W2, and it's the process data, so process data parser. We'll go ahead and import that. Go ahead and follow the wizard. Okay, that's fine. And we'll import our process data. That is an add-on instruction for the process data. Now, how do we utilize that? We go to our program. We'll add a subroutine. I'm going to call it the KTS IO-Link data. It'll be a ladder program, and then we'll just create a rung here to JSR to a subroutine, jump to a subroutine, make sure that we can go to the KTS out of our main program. All right, then with our KTS program, we're going to add a couple of points here. The first one is going to be a toggle bit. We can actually only utilize the, let's see if I've created it already. Yep, toggle bit. You can actually only utilize the process data or the service data. You can't do them at the same time. So what we're going to do is we're going to create this toggle bit, and then in the next rung we'll create a basically a reverse of the toggle bit that will allow us to put the process data on this first rung and then the service data on the second rung. So we can only request one at a time. All right, so we got one or the other. Then on our process data rung, we want to add in the process data parser. So process data parser, make sure it goes behind our toggle bit, and then we also want to add in a copy function. You can see, shoot, I don't want to delete it. We'll add it at the end and then drag it up just to make sure I'm not deleting it. We'll add a copy function and throw that in here. So I know that we have to add that copy function because I have looked at the instructions for our process data in the PDF file that gets downloaded with the add-on instructions. So if you want to jump to it, you can see copy function, data parser, and then we got to define each of these variables or tags. This first one is where's the data coming from, the master, and then the actual port number. We'll create an array to pull that data, then we'll create a memory location for the data, access the array, and then output the data. So I will fly through that here for us. So the source is our IO-Link master, Jake is awesome, and then all the data, and all right, which byte do we want to start on? Remember, back to our IO-Link master, we can see input data, and we're looking at port 2. Port 2 is where the KTS is actually connected, and it starts in 104. So back to Logix, we'll go to 104. 104. Then we'll create an array. So create an array. It's got to be a single integer, dimension 2. That's defined in our instructions. So we'll go KTS PD array. Create that one, and then length of 2. Then over here, so now we'll create our memory instance. Our data type pulls in because we're using the add-on instructions now. So KTS PD instance. Go ahead and create that one. Then the array will reference our array, PD array, and the process data. We are going to, create a tag for the process data using this data type, and this is going to be our output data. So KTS PD data. We'll go ahead and create that. So this is going to be our process data. We can verify this wrong, make sure we don't have any errors. Missing a reference to an array element. All right, so we don't know where to start on this array, basically, is what's going on there. So we do have to tell it to start at 0.0. Now we'll go ahead and verify the rung. No errors. All right, so that's our process data function. The next one I want to create is our service data function. So we'll go down to this next rung, and we'll find the service data for the KTS. I think it's this first one. Sure enough, KTS. So we'll move this guy after our toggle bit so that we are only running one at a time. And we'll start defining each of our data types and tags. So data type gets pulled in. So again, KTS, service data, Jake is awesome, iLink master, we'll leave it at that. So within all of our program, good. We'll create a new message. It's going to be a message. We're going to call this message 1. We know how to do this based on, again, this PDF, but you can see, actually, if we look at function block, here's the integration steps. It'll tell you, create message, it's data type message. And then for the definition on the message, we have to look on a different page, move up. Right here, we're using our balif master. Here's message 1, here's the definition, message 2, there's the definition. Let's go back, message 1, we'll open the configuration. I'm going to create it, service code 32. It's a source, we got to actually create a tag for that source. So we'll call that st, which is awesome, call data, and that is data type. Let's see that, st call data. That guy. St call data is st IOL data. So I'll get st IOL data. Call in our data type. Go ahead and verify that one more time in the integration steps. Message st IOL data. We go ahead and create that. Okay. Create it for message 1. Then our source is going to be basically what we just created there. So st call data, j call data, and it's the source, length of 1. You can verify that on our message definition. Message definition, st call data, message source, length 1, st destination data. Destination, length 1, communication path is to our iLink master. Okay, create that. That's message 1. We'll create another tag for message 2. It's message, we'll open the configuration. And then message 2 is very simple, 0000. Call data, same source, same destination, same path. All right. So st call data source, st call data destination. Length of 0, communication path is iLink master. Okay. And last tag we got to create here pulls in our data type for us. This we're going to just call our call data. So we'll go st Jake is awesome call data. Oh, we already got it created, huh? Call data. Maybe that was my issue. I didn't reference the same one. So st call data. There we go. Sorry, we don't create that tag we don't have to create that tag if we already did it in the message step. That's maybe an issue I had in the past. But all right, then we go down to our output data, device output data. We go ahead and read our new tag. Again, it'll have the description pulled in for us. So this is just our output data. So STJ's awesome KTS output. And then we can collect our error codes as well. So errors will come through STJ's awesome KTS error. We'll create that one as well. So now we've got each of our types created. You can fill in here. The master type is type 0 for the Balluff master. You fill it in if you got other masters. But port number, this one, the ports don't actually start recording at 0. So when we were looking up here at byte 104, there was port 0, 1, 2. So we would think this would be port 2, but it actually isn't. It starts numbering. This one's different. So it does number in this fashion. So we go 1, 2, 3, 4, 5, 6, 7, 8. Bottom right is 8. But if you're going to look at byte 104, then you would have to go 0, 1, 2, 3, 4, all the way up to 7. So this guy is 1, 2, 3. The KTS is on port 3 right here. So I'll go ahead and put that in just so that we don't have to do it later. Then we've got our information created at this point. So now I'll go ahead and verify this wrong. 0 warnings. Go ahead and maybe verify the whole program. We've got an empty rung somewhere. All right, it must be down at the bottom here. We'll go ahead and delete that. And that should be our only issue. Now we'll try to go online. So go online. We're going to download all this information to the PLC. Download. So once again, what we're doing here with the add-on instructions is just showing an easier way to read this data. You can do it manually through the web browsers or a couple other tables, but the process data and the service data come a little bit more cleanly if you utilize our add-on instructions, trying to make it a little bit easier on everybody. So to verify that we're working here, we'll go to our function block, KTS, ILink data. Right now the service data is set up. Let's go ahead and toggle it to be the process data and verify that we're getting our process data live. So to do that, we'll monitor our output. Go ahead and monitor the output. Here's our KTS output data, process data as it's coming through. It'll be read as Q of R alarm, quality of run alarm, emission color, and then measurement value of emission color. They're listed as hex, but it's actually, sorry, a decimal number. Change those to decimal. So the measurement value, 402. 402 is the number that we see on the top of the sensor right now. So I moved it a little bit, but 402, 403 is the number we see right here. We're going to also see that in the software. Mission color is 2. If you go back to the KTS data map for IO-Link, you'll see that the emission color is 0, 1, or 2. 2 is for blue, 1 is for green, 0 is for red. Quality run alarm is set really low, so we're not going to see that change. But then Q is our output. So if I put an object, a black object in front of the sensor, we'll get an output. We get a 1 right there. You'll see the amber LED on the sensor, but you get the 1. Then we move back and get back to 402. So process data is live. This information, you can take it and see it wherever you want to see it. Now we'll toggle it over to our service data. So service data, the way we request service data is, again, it's upon request. So here's our request bit. We change that to a 1, and we're saying we're requesting. The rest of them below here are saying what we want to request. So the first one I'd like to request, just to verify it's working, is vendor name. Pretty simple. We'll request the vendor name out of port 3. Go ahead and run the request. It says, yep, busy, and then done. Now let's see where it's output to. So I'll output our service data here. There it is. Our vendor name is SICK-AG. We see our service data coming across. So if we want to go back to our function block, we could say, all right, I want to see product name, product ID, system command, product ID, firmware version, application name, We can run down sensitivity. Maybe I want that. Maybe I want temperature. See if we can give us that one. Now we'll go ahead and run our request. Busy, done. Go ahead and monitor our output again. And here's our product name. We didn't get the system command. Here's the product ID again. See index 219. Firmware version. What else did we look for? Look for sensitivity. You can see that. Sorry, sensitivity in a decimal. Sensitivity set to 3. I happen to know is automatic. Temperature says 48. If we want to see what the temperature is, we could go back to our KTS output table. I'll look up temperature. Temperature, internal device temperature in Celsius. So it comes out straight up as a decimal number. We'll be able to read it as Celsius. So internally, we're looking at 48 degrees Celsius right now on the sensor. We could monitor that, see if we see some spikes, and maybe we're expecting some changes coming from there. If we wanted to write something to the device in a field that's optionable to be written into, essentially what you would do is you would come to whatever index you want to deal with. I'm not sure if I got one that'll work right off the top here. Device specific name maybe. Let's see if it's writable. Device specific name. Under name. Read only. Application specific tag. Let's look up that one. Application specific tag. Application name. Application name. We'll go ahead and write that in as Jake. Not the right one, huh? Application name. Application specific tag is read right. Come back here. Look for application specific name. Pick profile. Device specific name? Maybe that's what we're looking for. Or application name. Let's look at application name. Make sure it's the right one. Application name. Alright. So let's try to write one of these. We'll change our read-write bit to a 1 because we want to write actual information to it. And then when I run my request, then it's going to write that information into the sensor. So we'll request all this guy, application name. That's the one I want to write. Take output monitor. Apply. Okay. So now we'll go back here. We'll run our request. Easy done, really fast. And then we'll change it to a read. So just to verify, monitor. Got Jake written in there. You want to change that just to verify that it's actually going to change. I'll make it all stars. And then we go and we'll request our data. Change it to a 1. Request that data. Let's see that it's changed back to Jake. Jake. Boom. So we can write our data, return our data, whatever we need to do from there. Thank you for your time. We will have more videos showing other sensors.